Atom. An atom is the smallest unit of matter that retains the chemical properties of an element. Atoms consist of a nucleus, which contains positively charged protons and uncharged neutrons, surrounded by negatively charged electrons. The number of protons in the nucleus determines the element's atomic number and defines the element's unique properties. Atoms can combine to form molecules, which are the building blocks of all substances. The study of atoms is an important part of chemistry and physics, and our understanding of their properties has helped us develop many technologies that we use today. Nucleus. In physics, a nucleus is the central part of an atom, which contains most of the atom's mass and a positive electric charge. It is composed of positively charged protons and uncharged neutrons, collectively known as nucleons. The number of protons in the nucleus determines the atomic number of the element, while the total number of nucleons determines the mass number. The stability of a nucleus depends on the ratio of neutrons to protons, and some isotopes of certain elements can be unstable and undergo radioactive decay. The nucleus is held together by the strong nuclear force, which is a fundamental force of nature that binds protons and neutrons together. This force is much stronger than the electromagnetic force that repels positively charged protons from each other, which is why the nucleus can exist as a stable entity. The study of the properties and behavior of atomic nuclei is an important part of nuclear physics, and it has applications in fields such as energy production, medicine, and materials science. Proton. A proton is a subatomic particle with a positive electric charge and a mass slightly less than that of a neutron. It is one of the three fundamental particles that make up atoms, along with neutrons and electrons. The number of protons in an atom's nucleus determines the element and its unique properties. The proton was discovered by Ernest Rutherford in 1917 during his famous gold foil experiment, in which he bombarded a thin sheet of gold foil with alpha particles and observed how they scattered. He found that most of the alpha particles passed straight through the foil, but a small number were deflected at large angles, which led him to conclude that atoms have a dense, positively charged nucleus. Protons are composed of quarks, which are elementary particles that make up protons and neutrons. Protons are stable particles, and they do not decay into other particles under normal conditions. However, in high-energy particle collisions, protons can be smashed apart, releasing their energy and creating other particles. Protons play a vital role in chemistry and physics, and their properties and behavior are studied in various fields of science, including nuclear physics and particle physics. Protons are also used in medical imaging, such as in proton therapy, a type of radiation therapy used to treat cancer. Neutron. A neutron is a subatomic particle with no net electric charge and a mass slightly greater than that of a proton. It is one of the three fundamental particles that make up atoms, along with protons and electrons. The number of neutrons in an atom's nucleus can vary, creating different isotopes of the same element. The neutron was discovered by James Chadwick in 1932, through experiments in which he bombarded a beryllium target with alpha particles and observed the emission of neutral radiation. He concluded that these particles were neutral, and he named them neutrons. Neutrons are composed of quarks, which are elementary particles that make up protons and neutrons. Neutrons are unstable particles and can undergo beta decay, which means they can transform into protons or other particles. Neutrons play a crucial role in nuclear physics, as they are involved in the process of nuclear fission, which is used to generate energy in nuclear power plants. They are also used in scientific research, such as in neutron scattering experiments, which can provide detailed information about the structure and properties of materials. In medicine, neutron radiation can be used to treat certain types of cancer, such as brain tumors. Electron. An electron is a subatomic particle with a negative electric charge and a mass that is about 1/1836th of the mass of a proton. It is one of the three fundamental particles that make up atoms, along with protons and neutrons. Electrons are found outside the atomic nucleus in regions known as electron shells or energy levels. Electrons were first discovered by J. Thomson in 1897, through experiments with cathode rays. He concluded that cathode rays were actually streams of negatively charged particles, which he called electrons. Electrons are considered to be elementary particles, which means that they are not made up of smaller particles. They are negatively charged, which means that they are attracted to positively charged particles, such as protons. The arrangement of electrons in an atom determines the chemical properties of the element and how it reacts with other elements. Electrons play a vital role in chemistry and physics, and their behavior is studied in various fields of science, including quantum mechanics and solid-state physics. They are involved in chemical reactions, electrical conductivity, and the production of light. In technology, electrons are used in a variety of devices, such as transistors, microchips, and cathode ray tubes. Quark. A quark is an elementary subatomic particle and a fundamental constituent of matter. Quarks are found inside protons and neutrons, which are themselves made up of combinations of quarks. Quarks are never found alone in nature. They are always found bound together in particles such as protons, neutrons, and mesons. Quarks come in 6 different flavors: up, down, charm, strange, top, and bottom. These flavors have different masses and electric charges, and they can combine to form particles with different properties. Quarks also have a property known as spin, which determines their angular momentum. Quarks interact with other particles through the strong nuclear force, which is one of the 4 fundamental forces of nature. The strong nuclear force is responsible for holding the quarks together inside protons and neutrons, and it is much stronger than the electromagnetic force, which is responsible for the interactions between charged particles such as electrons and protons. The study of quarks and their interactions is an important part of particle physics, and it has led to the development of the Standard Model of Particle Physics, which describes the behavior of fundamental particles and the interactions between them. Quarks are also used in the production of energy, such as in particle accelerators, which can create high-energy collisions between particles to study their properties.